Hi class, this is section 5.1, Bisectors of Triangles. The learning target for today is that we will be able to use properties of perpendicular bisectors and angle bisectors to solve problems in triangles. First, let's do a quick recall of a couple of vocabulary terms. First of all, what is a bisector? A bisector is a segment or ray that divides a segment or angle in half. What does perpendicular mean? Perpendicular lines are lines that intersect to form right angles. So perpendicular means that whatever is perpendicular, whether it's lines or segments, they're always going to form those 90-degree angles. So what would a perpendicular bisector mean? It's a line, segment, or ray that is perpendicular to a segment at its midpoint. So it's going to cut it in half, and it's going to be perpendicular to the segment. Perpendicular bisector. So first we have a perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, so here we have a perpendicular bisector of this segment right here. It forms a 90-degree angle with the segment and it cuts the segment in half, which is why I have these two sides marked congruent. So if I have a point on this perpendicular bisector, then it is equidistant from the end points of the segment. So no matter what point I pick on here, it's going to be equal distance from this segment end and this segment end point. So for example, if I pick this point, these two dotted lines are going to be equal distant. If I pick this point, then these two lines are going to be equal distant. The converse of this is also true. So these are actually the definitions out of your book. A perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. So CD is the perpendicular bisector of AB, which means that AC and BC would be the same length, because this is a point on that perpendicular bisector. Remember, a converse just flips the hypothesis and the conclusion. So if we were to switch this definition or theorem around, it would say, if a point is equidistant from the endpoints of the segment, then it has to be on the perpendicular bisector. So since E is equal distance from A and B, which are the endpoints, that means that E has to be on the perpendicular bisector. So let's use this theorem to find some variables. Here we have a picture. This is our perpendicular bisector. I know because it's forming a 90-degree angle with the base, and it's cutting this base in half. So first let's start with finding x. I know that these two distances have to be equidistant since this point is on the perpendicular bisector. So I'm going to set them equal and get that x is equal to 4. I want you to pause the video and try to find y and z. It should only take you 30 seconds. So you should get that y is 15 and that z is going to be 6. All you had to do is set the two sides equal. Now we're looking at another perpendicular bisector problem. EG is the perpendicular bisector of AB, and it's the perpendicular bisector of DF. So if AG is, find AG if GB is 8. So if this is 8, AG would have to be 8 because they're congruent. Next one, find DC. So here's DC if DF is 20. Well, DF is the whole thing and DC is only half of it, so that means that DC would have to be 10. Find EB if AE is 9. Well, I know that these have to be equidistant because point E is on the perpendicular bisector. So that means that EB would also have to be 9. Find DE if EF is 15? Well, again, they're going to be congruent, so DE is going to be 15. Find AD, this little part right here, if EF is 10 and EB is 8. So I know that BF and AD are going to be congruent, so if this whole thing is 10 and the upper half is 8, that would mean that BF is 2, which would make AD 2. Alright, next theorem is an angle bisector theorem. If a point is on the angle bisector of an angle, then the point is equidistant from the sides of the angle. So here I have an angle, and then this is going to be my angle bisector. Here's a point on the angle bisector. That means that this point is going to be equidistant from both of the sides. So these two lines that I drew in are going to be the same distance. Whenever you measure the distance from a point to a line, always look for perpendicular distance. So always make sure that's forming a 90-degree angle with the sides. The converse of this is also true. So let's look at the theorems out of your book. So the angle bisector theorem is if point F is on the angle bisector. I know it's an angle bisector because it's splitting this angle into two equal halves. Then it is equidistant from the sides of the angles. So that means that FD and FE would have to be congruent. The converse says if a point in the interior of an angle is equidistant from the sides of the angle, then it's on the bisector of the angle. So since point F is equidistant from both sides of the angle, I can say that it's on the angle bisector. So let's start putting this to use. Given segment QS is the bisector of RQT, find X, RS, and TS. So QS is the bisector of this angle. To find X, I know that it has to be equidistant from both of the sides, so I need to set those two equal. So I'm going to get that X is equal to 3. That means that RS is 3 because RS is just X. To get TS, I need to plug in X. So I'm going to get the, I'm also going to get that TS or ST is also 3. They should be equal distance. They should both get an answer of 3. Alright, so now we're going to try some multiple choice problems using these theorems. Find the measure of NO. So here I have a perpendicular bisector, which means that the sides have to be equal distance from these two endpoints. So if this side is 9.2, then the other side has to be 9.2. Here I have a perpendicular bisector going through the middle of the triangle. I'm trying to find TU. So if this half is 4, the other half has to be 4 because a perpendicular bisector cuts the base in half. So our answer would be B. Find the measure of EH. Again, I have a perpendicular bisector, which means that these two sides have to be congruent because E has to be equal distance from H and equal distance from F. So first I need to find X by setting these two equal. When you set them equal, you should get that X is equal to 8. Then we need to plug that in to find EH. So 40 minus 20 is going to give me 20. Now I no longer have perpendicular bisectors, I have an angle bisector. It says find the measure of SR. Well, I know whenever a point is on the angle bisector that it's equal distance from the sides, so that means that SR would have to be 11. Find the measure of HFI. So here's angle HFI. Well, I know that this is an angle bisector because it's equal distance from the sides. So that means that if this side is 30 degrees, that the other side has to be 30 degrees. Find the measure of UV. Again, I can see that I have an angle bisector, which means that these two distances have to be equal. So, if you set those two equal, you're going to get that x is equal to 7. Then if you plug that into here, you're going to get that your answer is 19, because we're looking for the measure of UV. So 21 minus 2 is 19. That's the end of our notes. Please don't forget to fill out your WSQ, and I'll see you in class.